Hello class, I'm working out of your fundamentals book 1.6 Properties of Numbers. To begin with the commutative property of addition, we have an expression A plus B equals B plus A. And if we put values in for A and B, such as 5 for A plus 2 for B, we can switch those around on the other side for this expression, 2 plus 5. These are equivalent expressions. In the associative property of addition, we would have A plus B in parentheses plus C, equivalent to A in the front plus now B plus C in parentheses. We can use the associative property for mental math by grouping numbers because the property or the rule for these expressions say that in addition we can move these around when they have values to help us calculate an expression a little bit better. Let's look at an example of that. So if I have 39 plus 28 in parentheses plus 52, that would be equal to 39 plus 28 plus 52. Let's look. 8 plus 2 is some kind of 10. So if we say, oh, well, that 28 plus 2 is going to be a 30, and we add 50 to it, this renames as 80 right away in mental math. So now we have 39 plus 80. In the first expression, we would kind of have to grab that information for mental math and add our 28 plus 52. But this rule tells us that we can move these values to help us make calculations in mental math a little bit easier. If we finish this calculation, now we have 39 plus 80 equals 119. Another example is if we were to say 17 plus 31 plus 23 plus 19, as an expression, we can look and consider that 7 plus 3 and these two values equal some kind of 10. So if we group 17 plus 23, and then we think about 31 plus 19 as well, and group 1 plus 9 is some kind of 10, we can mental math these easier than trying to just add straight across because of the associative property of addition. 17 plus 3 is 20. Plus another 20 renames this whole part of the expression as a 40. Plus 1 plus 9 is 10. So 31 plus 9 is 40. Plus the 10 left over, 50. 40 plus 50 is 90. We also have the identity property of addition. You've been using this rule in expressions for a long time. Any value plus 0 is itself. We could also say the 0 plus a equals itself as well. So if we have 7 plus 0, we aren't adding anything to the 7, and our final answer is 7. All right. If we are multiplying by a power of 10, as in this example, like 40 times 20, we need to multiply our front end numbers and then place as many zeros as are in our factors. So let's do that process. 4 times 2 is 8. 1, 2 zeros that we're going to place after the 8 for our final answer from our factors. 40 times 20 is now 800. Let's try 40 times 2000. Anytime we get to the 1000s place, we need to start placing commas appropriately, so try that. Okay, we know from the last example, 4 times 2 is 8. Now we have 1, 2, 3, 4 zeros to place, and we do that. 1, 2, 3, 4 zeros. 1, 2, 3, place your comma appropriately, and our answer is 80,000. Let's try another one. 250 times 800. All right. 25 times 8. Think of 4 quarters in a dollar. 8 quarters would be $2. So based on your knowledge of money, 8 25s is 200. Outside of that 200, there are 1, 2, 3 zeros to place. Count back 1, 2, 3, comma. 250 times 800 is 200,000. Let's try 250 times 8,000. Again, 25 times 8 is 200. And then we place as many zeros as are in our factors. 1, 2, 3, 4. 1, 2, 3, 4. Count back to place commas. 1, 2, 3, comma. 1, 2, 3, comma. 2 million is our final answer here. So these properties, you've been using them for a while. They help you mental math and group numbers to help with expressions and make them easier. All right. Much like the properties of addition, there are properties of multiplication. The commutative property of multiplication, again, is set with a value of A times B equal to B times A. If we place values for A and B, such as 3 for A and 5 for B, that would be equal to 5 for B times 3 for A. We can see the equivalency of 15 equals 15 in the commutative property. In the associative property, we would have parentheses A times B in parentheses times C equal to A times parentheses B times C. If we place values for A, B, and C with an example. Let's try 1, 2, 3. Parentheses 1 times 2 in parentheses times 3 would be equal to 1 times parentheses 2 times 3. And we can see 6 would be equal to 6 here. The identity property of multiplication is also an idea you've been using for a long time. Now it has a name for the rule. I think I have a slide for it here. Here we go. We have A times 1 is equal to A. Any number times 1 retains its identity. So if we fill in a value 5 for A times 1, then it's going to equal 5. And 5 will retain its identity when multiplied by 1. Okay, there is a 0 property. So when I write this, we're looking at the 0 property of multiplication. Any number times 0 is 0. This is also a rule you've been using for quite some time. So if we have a number for A, such as 9 times 0, then that equals 0. Any number times 0 is 0, the 0 property of multiplication. Okay, the distributive property. You may have worked with this before. Now we're multiplying next to the parentheses. A would be multiplied by every part of the terms inside the parentheses. So A times B and A times C. With a plus sign in the middle. So let's look. If we have something like 5 times 38 in the distributive property, we could say that 5 is multiplied by a 30 plus 8. If this is true, then we know 5 will be multiplied by 30 and 5 will be multiplied by 8, and we can write that in our next line to see it, just so we can write out an expanded form and evaluate what's going on with it. And here we're back to, because of the nature of the distributive property, we can mental math. 5 times 3 is 15, and we place the 0 for the 30 from our factors, just like we did a few slides ago. So we can mental math 5 times 30 at 150, and then we're adding 5 times 8, and that should be a multiplication sign right here. So that's because we're taking 5 times 8 here. I wrote a plus sign, but it is a multiplication sign. Okay, we're going to add 5 times 8 at 40 after mental mathing our 5 times 30, and we would have 190 for our final answer. I hope this helps, and I'll see you soon.